DeitelCh, Chapter 6 and 8. This is our Mod 4. We're going to look at the PowerPoint movies for that as you go through. Hopefully the semester's going well for you so far. We're going to talk in here in more detail, going back and looking at those classes and looking at those in real detail. Introduction. Best way to develop and maintain large programs is to construct from small, simple pieces or modules. Divide and conquer. So we're going to look at things like static and method calls and how to do methods, and more methods. I also have a document out there on methods that we're going to look at together. Methods in a nutshell, and I think that's going to become one of them that's very important for you as you go through. Java programs combine new methods and classes that you write with predefined methods and classes available in Java Application Programming Interface, other class libraries. Chapter 6 talks about writing your own methods. Chapter 8 talks about using the one that Java provides when you do that. Related classes are typically grouped into packages so they can be imported into programs and reuse. In 9, there is another program called modules. We're not going to look at that, but the Java API is indeed very rich for having methods for you. So don't recreate the wheel. No one's going to pay you $100 an hour to recreate the wheel. Java has created an amazing number of classes out there for you to use. Again, we'll look at those in Chapter 8. Chapter 6, we're going to look about spinning up method classes yourself on ones that we want for our own use. So you should look at Chapter 8, which we'll get to, at the APIs as you go through and do that. So divide and conquer. Classes and methods help you modularize your program by separating its tasks into self-contained units. Programs are gigantic, the ones that are actually out there in the real world. And the only way to think them through is to divide them into small pieces, divide and conquer. Statement in method bodies, written only once, hidden from other methods, can be reused over and over from several locations in programs. You have small, simple pieces and software reuse. Use existing classes and methods as building blocks to create new programs as you go along. Okay, and meaningful methods to make the program easier to debug and maintain. So it's kind of like a hierarchical form of management. A boss asks a worker to perform a task, report back the results after completing the task. The boss method does not know how the worker method performs its designated tasks. Hiding or implementation of details promotes good software engineering. Now, you being the programmer have to write those details, but the driver programmer, the one that calls that, doesn't have to know what the details are for it to be able to use that method. How many of you know how system.println really works? Scan.nextLine. I don't know, okay? But it is a method that I know how to use it and I don't know the details of it. So the implementation of those were hidden by Java. We will do the same thing. We will write some methods and we will hide the detail from the driver program that uses it. Sometimes a method performs a task that does not depend on an object. Those are called static. That's a tough word. How to understand what the word static means, and we'll come back to that as we go through. We've looked at static methods. Main is static, public static void main string args, and we will look at how to actually use static methods when we go through and do that. Interestingly, when you call a static method, unlike the ones we looked at in Mod 2, it's class name .method. And again, there's more details of that in my methods in a nutshell. For instance, the math class has a collection of static methods that you can use to perform mathematical calculations. You don't have to make an instance of the math class to be able to use them. Again, math is part of java.lang, so we don't have to import it. And here's some background on actually doing that as you go through and look at that. And so here are some of the methods you can use in the math class, and we'll look at some examples of those when you actually go through. So there are some math constants which are interesting, math.pi, math.e when you actually do that. And those constants are final. Final for a constant, meaning it cannot be changed after it's initialized. We looked at that, I think, in Mod 1 a little bit, the concept of final. Why is the method main declared static? Because that's the way Java can actually get it to run to begin with. Now, we want to look at declaring methods with parameters and with multiple parameters. Okay, and when you have multiple parameters, you separate them by commas. There must be one argument in the method call for each parameter, sometimes called a formal parameter. Each argument must be consistent with the corresponding type of parameter. So arguments and parameters must match in number and data type. So if we look at this, and this is one where we have static methods when we actually do that. All right, if you look down here, we have created ourselves a static method called maximum. Okay, public, access modifier, static, because it is in, and the easiest way right now, and again, I'll talk to you this when I talk you through methods in a nutshell, is if you have a method in the driver, it's static, and if it's in the blueprint, it's not. Now, it's not quite that easy, but for us right now, that works pretty well. So I want to be able to always create, to be able to calculate over and over again the maximum of 3 doubles. So instead of writing this coding right there in main, I put a separate method. Access modifier, it's in the driver, so I have static, return type, method name, parameter list. That says if you want to use my method, you must supply me 3 doubles, and then I do some calculations. So if I then want to call it, I have to provide you 3 doubles. These are called the arguments. These are called the parameters. The arguments and parameters must match in number and data type. And so I ask you for 3 doubles, you give them to me, I send it in, return, again, where does that come from? Right here, I promised to return you a double. I returned you a double. There it is, okay? And that's what I can actually use to print out the answer as I go through. All right, variables should be declared as fields only if they're required for use in more than one method of class, or if the program should save their values between calls to classes. So you can actually use like math.max. Again, this is one that's provided for you, okay, from the math class. So it's class.method, and it's going to return the variety of max when you actually do that. They're going to talk in here about string concatenation as well. Okay, how to put strings together with a plus. We've talked about that before as we go through. It's a syntax error to break string literals across several lines. Okay, if necessary, you can split a string by using smaller strings by putting a plus sign in there. And I'll show you how that works as you go through. 3 ways to call methods. Method name by itself to call another method, a variable that contains a reference to an object, and a class name. So this right here is the key. It's the things that we really have to learn from chapter 6, or the three ways to do that. And again, I will work with you. Your book does an okay job. Okay, we'll work on it even harder than they do as you go through. But this is the crux of it all. Okay, if you use a method name by itself, it's because that method was in the same class. In my methods in a nutshell, I talked to you about that. Okay, if it's in a different class, you've got 2 choices. If it's static, you use className.method. If it's not static, you use object.method as you go through and do that. 3 ways to return control to a statement. Okay, when the program flow ends with a return or with return a value when you go through and do that. All right, so 3 different ways, and we're going to look at those in real detail as we go on. Declaring a method outside the body of a class is not legal, and you can't declare a method inside of another method. So make sure that your one method ends before your next method begins. Declaring a local variable in a method with the same name as one in the parameter list will not work because Java will not know which one to use as it goes through and does that. And forgetting to return a value from a method that has a return in the signature, okay, will be a compile time error. So you'll find those pretty quickly because they will not compile. Okay, if you don't want to return anything from method, make sure you make it void. Non-static methods are called instance methods, and that's really what we want to start looking at. Static methods can call to other static methods of the same class directly and manipulate static variables when you do that. But we want to really look at the ones that are for classes themselves as you go through it. And we'll be looking at that here and certainly in real detail in chapter 8, I guess it is. Now, argument promotion and casting, again, kind of a heavy-duty topic here, is all that says is that if a method is looking for a double and you provided an int, that's okay. because Java can take the number 5 and turn it to 5.0. If you are asking a method is asking to provide you an int and you give it 4.7, okay, it's not going to be happy because it doesn't know what to do with 4.7. And so there is implicit casting and explicit casting, and we will talk about both during this semester. All right, so we don't need to worry about this here. API packages, where Java provides stuff for us. There's a bunch of them here. Your book lists these when you look at it, and you'll find just an amazing amount. I probably know 5% of the entire Java language as we go through. It's just too much when you do that. Scope. We talked about scope once before. The previous module, scope becomes more important even here when you do that. Where can I, scope again meaning where can I use a variable? Okay, I can use a variable inside of main. If it's declared in main, I can use it inside of main. However, if in main it is declared, or under any other method is declared inside of a decision or a loop, it can only be used inside the decision or the loop as you go through and do that. Okay, so make certain that you understand that. If you have a block and you declare a variable inside a block, it can only be used inside the block. And so we do have to worry about that. Declare variables as close to where they're first used. Then you can find them a lot easier. Method overloading. What is method overloading? Method overloading says I have methods of the same name in the same class with a different parameter list. I've got to be able to let the compiler determine which version of the method to use. I may have a method called add that adds 2 variables, another method called add which adds 3 variables. Okay, and that's fine if indeed the parameter lists are different. So the different set of parameters. They can be in the same class, they just have to have a different set of parameters when you actually do that. Or a different data type. Sorry about that. So if I come back here and I look at this, I want to square integers, I want to square doubles. Okay, that's perfectly fine. Okay, but I could not have square int value and square int x. You can't just change the name of it. You have to change the parameter list. And then Java knows that if you're providing an integer, it will use the integer version. If you're providing a double, it will use the double version as you go through. That's how Java distinguishes by those signatures. It distinguishes which method to use. Common programming error, declaring overloaded methods with identical parameter lists. Java can't tell you which one to use. All right, so that's a real brief introduction to that and to some methods as far as static methods. We'll come back and look at static methods in more detail. The most important part about this module is Chapter 8. Actually looking at classes again. Actually looking at objects again and how classes and objects fit together when you do that. So he has a class called time in here, which I think is okay. Okay, I get a little tired of his example of time, and I'll give you a whole bunch of other examples as we go through, but this one's okay when you actually look at it. So he's got public class time to review what we did in Mod 2. Okay, it's a public, it's a class. This is our blueprint. I've got my fields here. Fields are private, data type, field name, or again, instance variables as well. Okay, he doesn't have any constructors yet. He'll get some in here in a minute, but he's got a set time method. Okay, where he passes in an hour, a minute, and a time, and a seconds when you actually do that. Okay, and again, does some data validation, which is wonderful. I don't know about this throws. I do, but we'll talk about those in Mod 7. He brings us in here, and I don't even care about this here. But this is where we're going to set the time, and he sets the value of the time. Now, if he was going to do that, I would have a constructor for this, and he will set this up with a constructor eventually. Okay, but again, I probably wouldn't have had a set time method because I could have done that with a full constructor. He actually has a string to set it to universal. Okay, and that's perfectly fine in a 2-string method. We will talk about the 2-string method. I will require them every time you use them. So a method like setTime validates all the method's arguments before using them when you actually do that. But again, I could do that in my constructor. Recall from Chapter 3, methods should be private. That means only these guys can use the methods. Only this class can use the methods. So he calls the no argument constructor because remember from our discussion in Mod 2, if you do not write a constructor, Java writes a no argument constructor. If you write one, Java will not write this for you. So he does the no argument constructor, and then he calls his set time method. If I knew those values, I would use a full constructor, which he will get to in a minute, so we'll get there eventually. All right. Notice we are calling time.setTime when you do that, because I am in the driver program, object.method. That's one way to use it, object.method. All right. And he does a try catch in here, which again, I don't think is necessary yet. Don't worry about that. We will get eventually to what we want to do. So it does not declare a constructor. So the compiler supplies one for us. Okay. Each instance variable implicitly receives a default value. Java does initialize fields for you. Java does not initialize local variables for you as you go through. Okay. Set time and throwing exceptions, do not worry about those exceptions that get thrown in here when you actually do that. So interfaces are less, again, change less frequently than implementation. So when implementing changes, implementation dependent code must change accordingly. Hiding the implementation reduces the possibility that other programs part will become dependent on class implementation details. Is all he's saying there is that if you write a method, okay, and then you go in and change how the method works, the actual details of it, as long as that signature stays the same, okay, it doesn't matter. It's not going to make a difference to your program. Controlling access modifiers, again, we've talked about public and private. Public, everybody can get to them. Your methods should be public. Private, only this class get to them. Your fields or your instance variables should be private. All right, as you go through and do this. So notice what happens here is that when he gets over into method access test and he tries to access the fields directly, you can't do it because it was private. And that's the best way to do that. So an attempt by a method that's not a member of the class to access a private member generates a compilation error. That's a good thing. Every object can access a reference to itself with the keyword this. We saw the keyword this in mod 2 and didn't talk about it much. We'll talk about it a little bit more as we go through. That means the current fields of the current object when you actually get there. Okay, when you compile a .java file, okay, it compiles into a .class file. And that's all they're doing. They say that once, again, he's putting things in this chapter we don't need, but when one source code contains multiple classes, the compiler places the classes into separate .class files in the same directory. Don't worry about that. We'll see that much, much later as we go through and do this. All right, so this used implicitly when you actually do that as you go through. So time equals new simple time as you go through. Simple time equals new simple time, and system.println time.pilled string as you look through that. All right, notice this constructor. This is what I want us to talk about, is this constructor, this. Here's the thing. Notice that the fields and the parameters have the same name. Whoa. So how's Java going to distinguish the two? Well, the first thing is don't name these the same. Don't name your parameters the same as your fields, and you'll be fine. Except we're going to see, and I probably already have shown you by now, by the time you're listening to this, how to let Java construct a lot of our code for us, to actually write it for us. Right-click, source, generate. We can generate the constructors. We can generate the getters and setters. Part of the problem is Java's got to put these parameters here, and what names is Java going to use? Well, it uses the same one as the fields. Makes sense. Okay, that's probably a way to do it. I don't know if otherwise you just have it guess values or something of that sort. I'm not real sure as you go through. Okay, and so it uses the same names, but we've got to be able to distinguish the field from the parameter. Okay, the word this means the current object, so that there refers to that, and this one refers to that one. Okay, so this dot anything refers to the field, and just the variable refers to that. Now, if these were named differently, I wouldn't need the word this here. I need the word this here because I can't just say hour equals hour. All right, and so this dot hour means the field, and that hour there is the parameter when you do that. We'll see that in the getters and setters. You can do that throughout everything. Okay, but you really don't have to do it here because there is no parameter named that, so it's not going to get confused on what it is as it goes through. We have 3 private instance variables. If the parameter names for the constructor that are identical to the instance variables, so they use this reference to refer to the instance variables. I can overload the constructors. I will make you overload the constructors I already have in mod 2. Okay, that allows classes to be, objects of classes to be initialized in different ways, and that's always good to leave it as flexible as you possibly can as you go through. To overload constructors, provide different signatures, same terminology, overload when you go that. To recall the parameter differentiates a signature by the number of parameters, the types of parameters, and the order in the signature. Arguments and parameters must match a number and data type when you call methods, and to overload, you have to have a different parameter list. So this guy, if I have it in here, he's got 5 different constructors. I can construct it by providing nothing. I can construct it by providing just the hour. I can construct it by providing the hour and the minutes. Okay, I can construct it by providing all 3 with some validation that I don't need to worry about, or I can actually pass in another time object to construct it. So you can have as many constructors as you want. And a lot of times there will be quite a few of them as you go through and do that. So you can look at that example in the book. It's a compilation error when this is used in a constructor's body to call another class's constructor if the call is not the first statement. Okay, and again, we'll see that later as we go through. When one object of a class has a reference to another object of the class, the first object has access to the second. And again, he's getting a little bit more detailed than he needs to. He's got this thing running for you. Here you go. I don't like his examples as much in this chapter as I do some of the others. Okay, and so we'll do a lot of work on our own together, okay, as we're doing this outside of his examples. I like his book. Some of the examples maybe aren't needed as much. All right, so he's got some overloaded constructor information there. The default and no argument constructors, every class must have at least one constructor. If you do not provide one, Java provides one. If you provide one, Java does not provide it. Okay, just keep that in mind. I will ask you to always write 2 of them, so I guess it really doesn't matter. Okay, we'll always make it work that way. So do not include a return type in the constructor. There is no such thing. We're constructing objects, we're not returning anything. Okay, and they really won't be constructors if you have a return type included. A compilation error occurs if a program attempts to initialize an object of a class by passing in the wrong number or types of arguments to the class. Getters and setters, got to be there, period. Okay, you will write one for every single field you have. Set methods called mutators, get methods called accessors. I went through a movie showing you my class template. It shows you everything you need to know about getters and setters. Okay, when you actually do that. And those are essentially going to be public, and that is how the user is going to get to your field when you actually do that. Now, you might think that that, as he says, that that's essentially the same as making the class instance variable as public, but it isn't, because I can write code in there that limits what the user can do or how the user gets to it when you actually do that. So it's really limited by the implementation in the methods, which is a good thing. Using setter and getter methods help you to create classes that are easier to debug and maintain. If only one method performs a particular task, such as setting an instance variable, it's easier to debug. Okay, and so we really want to look at that. We're going to go through that a lot more. He goes through that in the beginning of this, and I think he does it really quickly, because this is the guts. This is where we really need to understand everything about classes. And so I will have a lot of auxiliary movies for you when you go through. The last thing, which we will touch just briefly in here, and then we will indeed look at it in real detail in the next module, because that's kind of my philosophy, is to touch on something at the end of a module, really hit it in the next one, so you can kind of look at it twice. Okay, he calls it composition. I call it aggregation. Either way you want to do that. Or association, it's sometimes called. I think I call it association maybe. Has a. Okay, where one class can actually have an instance as a field of another class. Now, not too hard to think about, because that's going to happen all the time. Here's a date class I have. month, day, year. Used to have to write my own date class. They finally put a great one in DeitelCh6&8, so I use that one when I actually do my coding, but he has his own date class, which is fine here as you go through. Okay, so he's got a date class, 3 fields. He's got a static final, okay, field there when you actually do that. He's got a constructor. He's got a toString method. We'll talk about our toString methods. And then he has an employee class that actually uses the date class. This right here is the association, okay, or aggregation or composition. There's a little bit difference between the 3, but you can use whatever one of those terminologies you want. And all that means is, and we'll look at it in detail when we do our examples, is that there is a class, okay, as a field. Now, string, you'd say string is a class, but string is a little bit different. It only has one thing. A date has 3 things in it when you actually go through and actually do it that. And that's what he's talking about in section 8.8 in his composition when he does that. So I have to create a date, and I have to create another date, and then I actually use those when I create an employee object as we go through and do that. Doesn't do enough of that in there. We'll do a lot more of those examples as we go through. Talks about garbage collection a little bit, okay, and that's a good thing to know about is what happens to objects when Java's done with them? If they are sent to, used to be, in other languages, not used to be, but still in other languages, you actually write deconstructors along with your constructors that will deconstruct the actual objects. Java does it for you. It has a garbage collection that actually runs around, okay, reclaims memory occupied by objects that are no longer used. If there are no references to the object, they're eligible for garbage collection, and it typically occurs when the JVM runs through and looks for it. You can't tell it to do it. You usually don't need to tell it to do it. It'll usually go garbage collect when the program is running, okay, but when it's not being accessed at that point, or when you start running out of memory. And so you don't need to worry about it. Realize it exists, and it's not something that you need to deal with when you are there. You don't have memory leaks like in C and C++, because those don't automatically reclaim that memory. We do in ours. All right, the last thing he does in here is, again, those static class members. When you do that, it's stuff used for the entire class, and I will show you that as we go along. But you can have static fields when all objects must use the same code. Okay, they have class scope. They're used by all objects that are created in that class. And if you look at it, it's like this. We will use that if you want to count the total number of employees created. I probably wouldn't use it for that. I only use it, the only time you'll see me use it this semester is when I want to actually create an ID, an employee ID, and I want to make sure it's unique. And I will show you how I use that as we go through. All right. Final instance variables mean they cannot be, final just means that they're constants as you go through and do that. We've seen that as we go through. All right, so that's the end of that chapter. We'll look at a lot of examples. This is probably one of the most important chapters we've got. So work hard on it. Thank you.